With our first example for graphing, we have the equation y equals 4 to the power of x. So what we want to remember is we could have an a, a b, a k, all these different things. So we're looking for y equals a, b, x, and we're probably going to see a k here shortly. So looking at my equation, a is equal to 1, b is equal to 4, and I'm not adding anything. I don't see any numbers there, so that's telling me that k is 0. So our horizontal asymptote is going to be y equals 0. And looking at the value of b, before I even graph this, it's going to be a growth because b is greater than the number 1. And next, I am going to graph this on my calculator. So I'm going to jump to the calculator screen. We are going to put this on the graph and look at the table and get the values that we would like to put on our table before we graph this. On my calculator, in order to graph our exponential function, we are going to go to y equals, that upper left-hand corner. And under that first y equals option, we are going to hit 4. And then we are going to use that little arrow up that's above the divide symbol to make our exponent, and then x, which is next to the alpha button, the green button. So we should have a large 4 with a little tiny x on top. And to see what that looks like, we're going to go to graph. And here we can see it looks like our examples that we did on our notes of growth as it's going up to the right side, up and to the right. As our x's get larger, the y values are going to get much larger. So this is a growth, an example of growth. And we can then look at the table to get some of our table numbers to copy down onto our notes page and to graph it. So to do that, we're going to hit second and then graph to look at the table. As you notice, when the x's are negative, the y values get really, really small. If you arrow up, you can see they get really, really small when you see an E next to numbers. Those are very tiny, tiny decimals. So the y values get very small as the x's go negative, but as the x's get larger, the y values get much, much larger. As you can see, we jump from y values of 1 to 4 to 16, 64, 256 up into the thousands. So I'm going to copy down the numbers from -1 down to 3 for our x values. So -1 to 3, and those accompanying y values I will copy onto my table to take a look at, and then copy my graph down. So we use the calculator to graph our equation and to look at the table so we have an idea of what it looks like, and I copied down some of the points from the table. I don't need to copy all of them. I don't have to copy a certain amount. I say at least 3 just so that you know what points to plot and figure out what your graph's going to look like. So right now I have the x values -1 through 3 written down with their coordinating y values. I want to identify where my y-intercept is, which happens when x is equal to 0. So here is our y-intercept. And I'm going to plot these points and draw our continuous smooth curved line. So we have a point at -1 1/4, 0, 1, 4. And I can't really go any more than that, but we have an idea of where our curve's going to go and how steep it needs to be. So I'm going to connect those dots and make a very extreme slant to the top. Now looking at this, we can determine what our horizontal asymptote is. And we already determined that based off of the equation, but we can always double check that with our graph. And it's going to be y equals 0. So I'm just going to add a little dashed line, and I'm going to put HA for horizontal asymptote, and that is y equals 0. Now talking about the domain and range. Domain for all of these is going to be all real numbers. And our range is going to be y is greater than our horizontal asymptote, which is 0. Okay, so let's look at another example of this, graphing it on our calculator. So example 2 here has the equation y equals parentheses 1/4 to the exponent of x. So here I see I have a fraction between 0 and 1. So this is going to be our fractional decay. So this is definitely going to be a decay because b is equal to 1/4. We have an invisible a is equal to 1. And we're not adding or subtracting anything. Let me move this. And so we have that invisible k, which is going to be a 0. So our asymptote is going to be y equals 0 again. Now I'm going to jump back to my calculator, graph this, make sure I make it as a fraction, and come back and fill out my table. For example 2, we are going to type in y equals, and I'm going to type it in exactly as it's shown on my paper. So I see parentheses, so I'm going to utilize the parentheses, which are above the 8 and 9 button. And then my value for b is a fraction. In order to make a fraction, I'm going to hit alpha, the green button, and then the y equals. And I'm going to hit enter for option 1 to make our fraction, which is 1/4. I'm going to arrow to the right and close that parentheses, and then make our exponent of x. So this looks like example 2 from our notes. I'm going to go to graph. And looking at that graph, we can see it goes down as we move to the right. So this is going to be a decay. It starts off very high for the y values when x is negative, and as it moves down, that to positive x's, the y value gets closer and closer to what looks like 0. So if we look at the table by hitting second graph, we see our negative x's, like -5 is a positive 1024 for the y values. Those y values get very large. I'm going to start at -3 again, so -3 64, -2 16, -1 4, 0 1, 1 and 1/4. It's turning it into fractions for me, and then 2 and 1/16. So I'm going to copy those down into my table and then graph it on my notes, and then we can talk about the asymptote and the domain and range. Now looking at my table and at my graph, I know that my y-intercept, oops, I circled the wrong one. Our y-intercept is at 0, 1. And we also know that our domain is going to be all real numbers. And our range, looking at where our horizontal asymptote is, which is y equals 0, our range is going to be y is greater than 0.